Alright, so this is lesson 88 and the first part of it, and it's the distance formula. So, like with the slope, we've been calculating distance, we've been doing this, and now we've done it enough that we're finding the pattern that we've been witnessing. So, if I wanted to find the distance between 2 points, x1, y1, and x2, y2. Up until this point, if I wanted to find the distance between these 2 points, we would use the Pythagorean theorem, remember. We would plot the 2 points, make our triangle, and we're calculating the length of the hypotenuse. And that's what we're going to do here, only we have abstract points. So I'm going to plot 2 points. This is my, let's put him over this way, x1, y1. This is my x2, y2. And if I want to know the distance between, I want to know that length right there. And I'm going to do it. I'm going to find this distance using the Pythagorean theorem. So I'm going to make a right triangle first. I'm going to draw a horizontal part. And then I'm going to draw a vertical part. And there's going to be this point right here where the 90-degree angle is. And if we look at this for a minute, we can tell, we know what the coordinates of that point is right there. The x coordinate is how far left or right you go. And since this line is vertical, this point has to be as far left or right as this point. So it has a x coordinate of x2. And then the y-coordinate is how far up or down it goes. Since this line is horizontal, then this point goes up or down as much as this point. So it has the coordinate of y1. Now, the distance between these 2 points, this is, you came over x1 and then you came over x2. So the distance between those 2 points would be x1 minus x2. And the distance between these 2 points, you had to go up y2 and up y1, or down y2 and down y1. Okay? So the distance between these 2 points has to be y1 minus y2. This looks a lot like that slope formula that we just did. This one right here looks a lot like this. It's the same 2 pieces. It's the change in the y's and the change in the x's. That's my distance here. Now, this hypotenuse, I'm going to call it D, by Pythagorean theorem, we know that D squared has to equal to x1 minus x2 squared plus y1 minus y2 squared. Notice here, if we did y2 minus y1 and we got the opposite, instead of a -3, we got a +3. For example, once we square it, no matter whether we have a -3 here or a +3 here, once we square it, it's going to be positive. So the sign's not going to be of any concern there. So then, take the square root of both sides. The distance is going to be the square root of x1 minus x2 squared plus y1 minus y2 squared. So this is my distance formula. Again, once we know our pattern, we don't have to draw our pictures every time to find it. We just need to plug in the values into our pattern. For example, the practice problem says find the distance between the points 4, -2 and -3, 1. So the distance between those 2 points would be the square root of 4 minus -3 squared plus -2 minus 1 squared. Negative minus a negative makes it a positive. So it's going to be the square root of 7 squared plus -3 squared, the square root of 49 plus 9. So the distance between these 2 points would be the square root of 58.